Lesson 12.1, Task 3. Multiply rational expressions. Multiplying two rational expressions is like multiplying two numerical fractions. First, multiply the numerators, then multiply the denominators. Simplify the product by canceling any common factors appearing in both the numerator and the denominator. Alright, so let's blow this up a little bit, make it easier to see. So we're going to multiply x squared minus 3x minus 10 over x squared plus x minus 20 by x squared minus 16 and x squared minus 4. Alright, so to find the excluded values, the first thing you have to do is have everything in factored form. Also, if you want to cancel anything out from top to bottom, it needs to be in factored form. So before we multiply, we first need to factor. Alright, so what we're going to do is look at each expression individually. So let's look at the x squared minus 3x minus 10. So if we want to rewrite this in factored form, we're going to rewrite this as a product of two binomials. So we're going to have x times x, what multiplies to give us negative 10 and adds to give us negative 3. All right, if it helps to write this little thing down, I don't know what it's called, but when I was in the classroom, my students liked to do this. They could visually see what their factors were going to be. So 2 times 5 multiplies to give me 10, and there's 3 apart. I need a negative 3, so it's going to be a negative 5 and a plus 2. 2 times negative 5 is negative 10. 2 plus negative 5 is negative 3. So I know my factors are going to be x plus 2 and x minus 5. Alright, now I'm going to do the denominator, x squared plus x minus 20. So again, I'm going to factor this into two binomials. And I need something that multiplies to give me negative 20. And because there's only an x in the middle, that means there's a 1. So I've got 1 and 20, 2 and 10, or 4 and 5. So I know 4 and 5 are only 1 apart. So I'm going to have 4 and 5, and I need a positive 1. So 5 has to be positive, 4 is going to be negative. So I'm going to have negative 4 and plus 5. Alright, now I'm going to factor my difference of squares. Now, both of these are a difference of squares. This is something very important that you need to know. ACT, you see these a lot, and they're very easy to do. If you have a perfect square minus a perfect square, it's called a difference of squares, and those are a product of two binomials with different signs. So I'm going to have x plus 4 and x minus 4. If you don't remember how to do difference of squares, please look that up. Again, very easy if you know what it is. If you don't, it's going to be hard to do this whole unit because we will be factoring throughout this whole unit. Alright, so we have x squared minus 4. That's going to be x plus 2 and x minus 2. And then we can see all of our excluded values come from our denominator, which is all of the denominator in both of these. So it says, what are the excluded values? So 4 minus 4 is 0. Remember, anything that makes the denominator 0 is an excluded value. So 4 would be an excluded value. Negative 5 plus 5 makes this one 0. So negative 5. Negative 2 plus 2 is 0. So negative 2. And then 2 minus 2. So there are 4 excluded values in this expression. Now, I'm going to leave my factors up, but I'm going to get rid of this just so that we can scroll down through here and see what our other questions say. Alright, you'll see that they went through and did the same thing that we did. So they went through and factored everything. They actually put it together. I have a dot here that shows that the whole numerator is together and the denominator is together. They just kind of wrote it together. They went ahead and canceled out any common factors. So let's go ahead and cancel out our common factors. So we've got x plus 2 on top and bottom. We've also got x minus 4 on top and bottom. So that leaves us with x minus 5 times x plus 4 over x plus 5, and x minus 2. And you can see that that is the same thing that they have here. All right, so it says explain how the factors shown in the numerator and denominator were determined from the trinomial. Okay, so again, we just factored. So the two trinomials, x squared minus 3x minus 10 and x squared plus x minus 20, each factor into the product of two binomials. And the first one went to x plus 2 and x minus 5. And the second one went to x minus 4 and x plus 5. I explained how the factors shown in the numerator and denominator were determined from the binomials. Okay, so they're talking about the difference of squares here. So the two binomials, x squared minus 16 and x squared minus 4, are the difference of two squares, which each factor into the product of a sum and a difference. So we had it x plus 4, x minus 4, x plus 2, x minus 2, so that is a sum and a difference of the same binomial. So x squared minus 16 is equal to x plus and minus 4, and x squared minus 4 is equal to x plus and minus 2. All right, it says which equivalent expression for, or what equivalent expression for the product could be given. All right, so at this point, we've simplified everything we can do. So now it's the product means we just multiply it back together. So that's very simple as well. So we just say x times x is x squared, and we have plus 4x minus 5x, which is negative x, and then negative 5 times 4, which is negative 20. So that's on top, and then we have x times x, and then we have minus 2x plus 5x, which is plus 3x, and then 5 times negative 2, which is negative 10. So when we multiply using distributive property, we get x squared minus x minus 20 over x squared plus 3x minus 10, and that is the only expression that it could be. All right, that's all for task 3. If you have any questions, please let me know. Lesson 12.1, task 4. Divide rational expressions. Just as when dividing two numerical fractions, dividing rational expressions involves multiplying by the reciprocal of the divisor. The remaining steps of the process are those for multiplying two rational expressions. All right, so again, if we divide rational expressions, we're going to do the same thing as multiplication, except we have to multiply by the reciprocal of the second fraction. So here's an example. All right, so if we're dividing this expression by this, the first one stays the same, and then we multiply by the reciprocal of the second one. Then that way we can factor, reduce, find the excluded values, and anything we need to do from here. Okay, so division is the same, except we're going to multiply by the reciprocal of the second term. All right, so let's look at how to factor this expression. This is kind of a long one. All right, so it says x cubed plus 6x squared plus 12x plus 8. This looks like the most complicated one, so let's come back to it. All right, so let's factor the bottom one here that says x squared minus 12x over 32. So I'm just going to put a line here. We're going to come back to the top. We're going to factor x squared minus 12x plus 32 because we know that's going to factor into two binomials. So I'm going to have x times x, what multiplies to give me 32 and adds to give me negative 12. So that would be negative 8 and negative 4. Negative 8 times negative 4 gives me a positive 32. Negative 8 plus negative 4 gives me a negative 12. So now we factored the denominator here, and we're going to multiply by the reciprocal of this term here. So we've got x squared minus 64. We know that that's a difference of squares. So I'm going to have x plus 8 and x minus 8. And again, the order does not matter. All right, so now we have x cubed plus 8. X cubed is a perfect cubed, and 8 is a perfect cubed. 2 cubed equals 8. So this is a sum of cubes. We also learned how to factor that previously. So if you need to go back and review factoring sum and difference of cubes, please do so. I'm going to go through the process here as we only have a little bit of time. So we're going to have x cubed plus 8 is going to be x plus 2. Again, 2 cubed is 8. Then we're going to have x squared. We're going to have minus ab, which is minus 2x. And then plus b squared, which is 4 in this case. All right, now that I've factored everything, we are going to go back to this cubic term. All right, since I have all of these factors here in the denominator, I'm going to see if this will divide into this. So we can use synthetic division. So I'm going to take my smallest factor. I'm going to take negative 2. Remember, if I've got x plus 2 as a factor, I can take negative 2 and do synthetic division with a polynomial. So I'm going to pull out 1, 6, 12, and 8. And again, we learned this in a previous unit. My 1 drops down. Negative 2 times 1 is negative 2. I'm going to add, multiply, add, and multiply. And that cancels and gives me 0. If my remainder is 0, that means this is a factor of that polynomial. So we know that x plus 2 is one factor. And if x plus 2 comes out, we're left with 1x squared plus 4x plus 4. And this is my other factor. Okay, so we had to use synthetic division here. You could also use long division, but because that's a cubic term, we couldn't do grouping because I've already tried, and so we had to use division. All right, so now that we are finished dividing, I'm going to get rid of this. Oh, sorry about that. It took longer than I thought. All right. Let's see what our questions are for this problem. All right, so what are the excluded values? All right, the excluded values come from the denominator. So we can see right away that 8, because 8 minus 8 is 0, so 8 is an excluded value. 4 minus 4 is 0. Negative 2. And this one's a quadratic, so let's look at the graph and see what it looks like. Remember, if it crosses the x-axis, it has excluded values. If not, then it would have imaginary solutions. So let's see what this looks like. So hit clear, and I'm going to do x squared minus, let's see, x squared minus 2x plus 4. I'm going to hit graph. We're looking for where it crosses the x. It does not cross the x. So there are no excluded values that come from that last expression there. Okay, so this would only produce imaginary solutions here. All right, so this should be it. All right, it's saying there's another one. It's not that one. It's not that one. All right, they're saying negative 8 is a solution. I don't know how they got that. We are going to say this is not a solution. This is an error.